Now that concept of a voltage drop is going to make a little bit more sense in a second when I explain a little more about how voltage works in circuits. So you'll see here on the left, I've drawn a picture of a circuit with no resistor, and I've written under it wire with resistance. Now the reason for that is in a circuit, the total voltage is equal to the voltage of the battery. But what happens is that when you start at the positive terminal, none of the battery's strength has been used. In a real wire, which has resistance, it's going to take up some of that strength as the electricity travels, and by the time it gets to this negative terminal of the battery, the voltage will be at zero. Now this is actually true of any circuit. What's going to happen is that it's going to start at the positive terminal, it's going to have its full strength available, and then as it travels, it's going to end up going to zero. That's true even if there's a resistor. So in this second example, which is probably something you'll see much more often, we start again at the positive terminal, and in this case, you're going to typically assume that there's no resistance in the wire. So it doesn't take any of the battery's strength to move electricity through there. It goes there with no impedance whatsoever, and then it gets to the resistor, and it takes a lot of strength to go through. So then what happens is there's that voltage drop because the battery's strength is being used to push electricity through there, and then it goes back through the wire. Again, it doesn't use any strength, and by the time it gets here, it's at zero. So in an extremely simple circuit like this, we're going to see that the resistor's voltage drop is actually equal to the battery's voltage. But the important thing for you to take away here is that in any circuit, you're going to start at the positive terminal, and as you travel around the circuit, by the time you get to the negative terminal, the voltage should be at zero. So let me just write that out for you. So again, just to restate that, you start at the positive terminal, and that starts with the positive voltage of the battery. So if the battery is 9 volts, you start with 9 volts. And then as you travel around, any resistors that you encounter are going to decrease that, or if you were traveling through an actual wire, the resistance of the wire would decrease that because it takes up some of that strength for the electricity to travel. And by the time you get back to the negative terminal of the battery, you're going to use up all of the voltage, all of the strength of the battery, and you're going to end up with zero. One last concept that's important to understand DC circuits is that it's the net current that's constant. So that means that the overall rate of the movement of electrons, the overall rate of electricity flow is constant. However, the current at this point or this point may be different from each other, but the overall current, if you look at the entire circuit, is going to be the same independent of time. So just to recap what you've learned, we've gone over what a battery is and how it works in a DC circuit. We've gone over the very conceptual basics of what a resistor is and how it affects a circuit. We've gone over the difference between current and net current and the fact that net current is constant in a DC circuit. And we've gone over the very basics of voltage in circuits. Thanks for watching.